So let's say, suppose I have a function here, and here I have its mirror image. It's reflected about y-axis. So what happens here? So if I have, suppose this x is a and this value is b. So when I look at negative a, what will I get here? Negative a comma b. Because it's a mirror image. It's the same distance away on the other side. So if this is f of x, right? So what is f of negative x? Y at negative x. This is same as the y at positive x. If f of negative x is equal to f of x for all values of x, then it is called an even function, and it is reflect across the y-axis. Do you know any function like that which is symmetric about the y-axis? Y equals x squared. Yes, it does look like it should be symmetric, right? So let's try that. So f of x is x squared. Let's try f of negative x. What is that equal to? Instead of x, I need to put negative x. And always remember to use parentheses, otherwise you get it wrong. When you plug in something for x, use parentheses, particularly if there's a negative or a fraction in there. What is this equal to? This is x squared because negative times negative is positive. And then x squared is equal to f of x, right? So f of negative x is always equal to f of x for this example, right? That means this is even. Do you think this is symmetric across y-axis? So this should not be even. So let's test it out. F of x is x cubed. So f of negative x is negative x cubed, which is equal to. So this is not equal to f of x, right? Because f of x was x cubed, this is negative x cubed. So f of negative x is not equal to f of x. So this is not even. We were checking if it is an even function. What function is this? Cosine, right? Because it's starting at 1 here. Do you think this is even? It's symmetric, right? So it is symmetric. So this should be even. So how can we check? Cosine of negative theta or negative x. What is that equal to? So if you look in the, suppose that is theta, negative theta would be here. So on the unit circle, cosine of negative theta is this, and cosine of theta is also the same. On the unit circle, the x coordinate is cosine theta. So whatever is theta, negative theta will be its reflection below, but they will both have the same x coordinate, right? Even if it was here, then this will be the negative, right? And they will have the same x coordinate. So cosine negative theta is equal to cosine theta. So if this is f of negative theta, this is f of theta. So that tells you it's even. So cosine theta is even. And we also saw quadratic is even, cubic is not even. And not every quadratic would be even, because if you shift it over to the right, then it won't be a reflection anymore. So that's not going to work. So for example, if I have y equals x minus 2 squared. So this is f of x. If I try f of negative x, this will be negative x minus 2 squared. And you can see already these are different things. They're not the same because this is negative of x plus 2 squared. If I factor out the negative, and then negative squared is just positive, and then it becomes x plus 2 squared. So this is something else and this is something else. They're not equal. So not even. And you already know why, because this is just the parabola shifted to the right. So instead of this parabola, it is shifted right now. It's not symmetric on the y-axis. So either you can check by doing this, or you can check from the graph to figure out whether it's even or not.